Okay, so now on to the next example. If we want to solve a problem like this, 3 over x plus 5 over x squared equals 2, there are a couple ways to solve this. I think the easiest, though, is what's called the common denominator method. And so we see that we have an x here and x plus 2 here. So our common denominator is x times x plus 2. So I'm just going to multiply the whole equation, both sides, by x times x plus 2. So now, if I multiply 3 over x by x times x plus 2, the x's will basically cancel out, and I will get 3 times x plus 2, and then I won't have any denominator. Plus, now if I multiply 5 over x plus 2 by x times x plus 2, the x plus 2's will cancel out, so I'll get 5x. Okay, and then if I multiply this, I'll get, let's see, what is this? This is x squared plus 2x. So then I'll get 2x squared plus 4x. Okay, and now I see that I have an x squared, so I know that it's going to be quadratic. So now I need to get all my variables on one side and a 0 on the other side. So I will have 2x squared plus 4x minus 5x minus 5x. So this will be a 3x plus 6. So I'll subtract 3x, and I'll subtract 3x, and I'll subtract 6, and I'll subtract 6. So then if I simplify this, this whole side goes to 0, and I'll get 2x squared plus 4 minus 5 minus 3. So let's see, that's minus 4x minus 6. And now I need to see if I can factor this. So I say, okay, let's see, factors of negative 12 that factor out to negative 4. So I have that, right? It's so negative 12 is negative 6 and positive 2. So I can do 2x squared minus 6x plus 2x minus 6. Get my common term from here is a 2x, and I'm left with x minus 3. Plus, if my common term from over here is 2x minus 3. So now if I bring those together, if I factor out my x minus 3 basically, I'll get 2x plus 2, 2x plus 2, times x minus 3. And that equals 0. And then my 0 property of equality tells me to set both of these equal to 0, right? So I get 2x plus 2 equals 0. I get x minus 3 equals 0. So if I solve this, subtract 2, 2x equals negative 2, divide by 2, x equals negative 1, plus 3 to both sides over here, I'll get x equals 3. So there are my two answers, x equals negative 1 and x equals 3. Let's just go back to the original problem, because we have to see if either of these answers are outside of the domain. They aren't, because neither of them would make the denominator 0, so those are my two answers. Okay, so my next example is x to the 4th minus 8x squared plus 8 equals 0. Okay, so this one looks pretty crazy, right? We have an x to the 4th and an x squared. I don't know what to do with that, but I do know that I can rewrite x to the 4th as x squared, and then minus 8x squared, right? The parentheses do nothing there, plus 8 equals 0. But, so now I have something squared, something to the 1st, plus something. So it's quadratic. So let me just rename x squared. Let's just say x squared equals, I don't know, let's call it a. So I have a squared minus 8a plus 8 equals 0. Okay, so now I just have this normal quadratic here, right? Unfortunately, I can't factor it, so I could complete the square, or I could do the quadratic equation. The book does the quadratic equation, so I'll go with that. So the quadratic formula tells me a equals negative b, so my b value is negative 8, so 8 plus or minus the square root of negative 8 squared minus 4 times my a value is 1 times my c value is 8, all over 2 times my a value, which is 1. Okay, so I did a little simplifying, and that comes out to 8 plus or minus the square root of 32 over 2. Let's see, square root of 32, I can simplify that a little bit, right? Because 16 goes into that. So this is really 8 plus or minus the square root of 16 times the square root of 2. And I know the square root of 16 is 4, so this becomes 8 plus or minus 4 square root of 2 over 2. And now this has a 2 and this has a 2 in it. So this really becomes 4 plus or minus 2 square roots of 2 equals a. But a, if we remember, was x squared, right? So I know that x squared equals 4 plus or minus 2 square roots of 2. So now I have to take the square root of both sides. So remember, when I do the square root, I have to do plus or minus the square root. So really what we get is we get x equals plus or minus the square root of 4 plus or minus 2 square roots of 2. So there are going to be 4 different answers for this. There's going to be, so if we take the positive one first, it will be the square root of 4 plus 2 square roots of 2. There'll also be the square root of 4 minus 2 square roots of 2. And now we'll take the two negative ones. So the opposite of the square root of 4 minus 2 square roots of 2. And the opposite of the square root of 4 plus 2 square roots of 2 over 2. And we know that there should have been 4 solutions because if we remember, our original problem had a degree of 4. And we remember the fundamental theorem of algebra says that you can have as many roots as there are degrees of your problem. Okay, on to the next example. I have 2x equals 1 minus the square root of 2 minus x. So now I need to figure out how to get rid of this square root. So the first thing I need to do is get everything else onto the other side. So let's just subtract 1 from both sides, minus 1. My pen's running out, so I gotta find my other pen. Minus 1, minus 1. So I get 2x minus 1 equals negative the square root of 2 minus x. Okay, and now I have the square root, right? So I need to get rid of that. So let's square both sides. Square that. Square that. So when I square this, I will get, if we remember our expansion rules, we will get a squared, so 4x squared, minus 2ab, so minus 2 times 2x times 1. So that is, what is that, 4x, and then plus b squared, so plus 1, equals 2 minus x. So let's bring everything over. I have an x squared, so that means it's quadratic, so let's bring everything over. Let's subtract 2. Let's add x, so plus x minus 2. So I get 4x squared minus 3x minus 1 equals 0. So do I have factors of negative 4 that add up to negative 3? I think I do. I think it is, I think it's negative 4 and positive 1. So I have 4x squared minus 4x plus 1x minus 1 equals 0. So then if I group these together, my common term from those is a 4x, and I'm left with x minus 1. My common term between 1x and 1 are so 1, and I'm left with an x minus 1. So then if I bring everything together again, if I factor out the x minus 1, that is to say, I get 4x plus 1 times x minus 1 equals 0. So the multiplication property of 0 says that one of these two has to equal to 0, right? So then I get 4x plus 1 equals 0, 4x minus 1 equals 0. So then minus 1, 4x equals negative 1, divide by 4, I get x equals negative 1/4. Over here, add 1, x equals 1. Okay, so these are my two answers. But I know that I started with the square root problem. And when I start with the square root problem, what I know is that sometimes I might get answers that don't work. So what I'm going to do is I'm going to plug these two answers that I got into my original equation. So I'm going to do them one at a time. So let's first do the negative 1/4. So I get 2 times negative 1/4 equals 1 minus the square root of 2 minus negative 1/4. So then I get negative 2/4 equals 1 minus the square root of 2 minus negative 1/4 is really 2 plus 1/4. So that becomes 9/4. If I remember my square root rules, I can say that this is really 1 minus the square root of 9, which is 3, over the square root of 4, which is 2. So I get negative 2/4 is the same as 1/2, so negative 1/2 equals 1 minus 3/2. 1 minus 3/2 is negative 1/2, so I get negative 1/2 equals negative 1/2. So that one worked. Let's check if plugging in 1 works. So I'll get 2 times 1 equals 1 minus the square root of 2 minus 1. So I'll get 2 equals 1 minus the square root of 2 minus 1 is 1. 1 minus the square root of 1. So I'll get 2 equals, the square root of 1 is 1, so I get 1 minus 1. So 2 equals 0. So that doesn't work. So my only answer that actually satisfies this problem is this one up here, the 1/4. So that will be my answer. X equals negative 1/4.